Advanced Maths, Paper 1, 2021, Question 11, Memo with Explanations. It's not going to help you very much merely watching this video or reading through the memo. You really need to practice yourself, so here's some suggestions for effective revision. Don't practice questions which you firmly know that you could do. Rather select the questions on topics where you know that you will have difficulties. The only time you start practicing full papers is when you're trying to reduce your time taken to do the paper. If you become stuck at a question, yes, watch the video. Then it's vital you attempt the question yourself, preferably a day later, in order to test your understanding rather than your short-term memory. The very best way to revise maths is quality versus quantity. It's more effective to complete fewer revision papers completely and correctly, ultimately without having to refer to help of any form, than to complete as many papers or exercises as possible. Confucius said, "What I hear I forget, what I see I remember, what I do I understand." So here we have an optimization question. Man standing 30 meters away from a bank. So that's a right angle. We measure distance as perpendicular. 100 meters downstream, there is a stream. So go 100 meters down, there is a tree. There's a tree, not a stream, which is 50 meters from the river bank. So also perpendicular distance. He wishes to walk to the river to drink and then to the tree to rest in the shade. He walks in straight lines as depicted by the dotted line. So he walks to there and then up to there. Show that the distance he'll walk is given by the expression. Once again, this show, all it's saying is find the distance in terms of x. By the way, here's the answer. So that you don't have the correct, incorrect one to use further. And also the other thing, if you have trouble with this, there's no harm in going on to the next section. You're crazy if you don't. If you can't get this one, you can at least use it in the next part of the question, which will clearly be the optimization, where you need to differentiate. So we're going to find that distance there. Well, Pythagoras' theorem will help us here. That squared plus that squared, square rooted. This one here will be 100 minus x, because that's x and that's 100. So we can use Pythagoras to get that distance as well. So there are distance to river, x squared plus 900 square rooted. Distance to tree, 100 minus x plus 50 squared, square rooted. So therefore the total distance walked is that, adding the two together, and there we are. Now it says, hence determine the value of x which will minimize the distance d. I'll put that for you so you have that. I've taken away the diagram only because we don't really need it now, because we're just optimizing this expression, expression here, and our needed space. We're going to differentiate. So let's write it in the way that it's okay to differentiate. Right, dd by dx. I'm not stuttering, it's d by dx of d. So these are now chain rule questions. Half into the x squared minus 900, x squared plus 900 to the negative half, times the derivative of the inside 2x, plus half into that, stays the same, to the negative half, times derivative of the inside 2x minus 200. Now I'm trying to solve, you see, for x. So I've got it equal to naught. So what I've done is I've taken this one across the other side with a bit of simplification. Yeah, simplifying on both sides. To get there, I've squared both sides to get there. So let's show you again. We've differentiated using two chain rules, put equal to naught. I'm now solving for x, so I move this whole term to the other side. I've written it back with that as a square root underneath, and half of 2x minus 200 is x minus 100. I've written that as a square root below, and half of 2x is x. Now I've squared both sides in order to get rid of the square root signs. Oh, square the top and just drop the square root. Square root up, drop the square root. Now I've got to multiply, or cross multiply. I hate using that, but it's true here. So x squared times that denominator, that's what we get there, is equal to that times that denominator, and that's what we have there. And that gives us that terrible quadratic to solve. But don't forget that you can solve quadratics on your calculator. You go mode 3 and you look at equation, and then you look for the type of equation, which is a quadratic. You'll see it there. And we solve, we get 37,5 meters. There'll be a negative answer which you'll reject. 11.2, area below curves or between curves. Determine the area labeled A below. It's bounded above the curve. There, it's bounded above. It's bounded above by the curve, so it's above by that curve and below by this curve, and to the left of that and to the right of that. So it is this area here. You should show the expression of all the integrals which you use to calculate your answer. Now, this area here is going to be the area under the top one minus the area under the bottom one. So that's the integral from 3 to 9 of that function dx minus the integral from 3 to 9 of that function dx. Because they're both integral from 3 to 9, I can combine them into a single integral. Now I've substituted the values and I've integrated. And it's from 3 to 9 because it's a definite integral. Notice we don't need a c because this is a definite integral. Substitute the 9 in, substitute the 3 in, and use a calculator to find your answer. 9.66 units.